Welcome guys to today's class on practical physics. In this video, we want to discuss experiment on rectangular block prism. We have posted the first part of it. This is the second part of rectangular block prism, where we will have a radius, a circle, and all have you on the experiment. So we want to see how we can perform this experiment without touching apparatus. And that means we want to use formula method to appreciate it, so that if you are given such experiment where there is no light or where there is darkness, you will be able to perform it because you know the formula method. Now, first thing to note why using formula method to solve any question on experiment or to perform experiment on any aspect of practical physics, what you do is, for this question now, we have to note what our refractive index means. Yes, it's coming from light. This light ray is coming from air and it's entering the glass and going. So refraction tends to exist because there is change of medium from air to glass to air. So from air to glass, it will reflect toward the normal, then to air, it will reflect away from the normal. This is the pin. This is the traces of the light ray. Yes, light ray, it's moving this way. That is the direction of the light ray. This is rectangular block prism. And look at a circle made on it with a radius. Now, what we do first is that we have to recall Snell's law, which says that the refractive index is sine I all over sine R. We have to note this. We have to also recall our SOHCAHTOA. SOHCAHTOA, that is sine equal to opposite over hypotenuse cos adjacent over hypotenuse tan opposite over adjacent. We have to recall that. Now, what we have to do is, first, get this diagram out, bring it out. That means this is my radius, this is my A, this is my perpendicular line. So this is my A, my R, and my I. Then the next one is to bring out this. So this is your R. That is, at this point, this is your refraction. This is your radius. This is your radius. Then this is your B. Now, the implication is that this is your radius, because we say radius is the distance from the center of a circle to any point on the circumference. From the center to any point. So they will have the same word, radius. But their A and B will not vary, and their I and their R, that is the angle of refraction, will not vary. So for here, it means that the R will be constant, but the I and R will not be constant, and the A and B will not be constant. So for this part, the formula we use is, we are looking for A, and we have opposite, we have hypotenuse, we have angle. We say sine I is equals to what? Opposite over hypotenuse, A over R. Therefore, A, which you are looking for, equal to R sine I. That is the formula we'll be using for this. We say A equal to R sine I. Then for this one, this is B, this is R. So we now say sine angle of refraction is equals to opposite over hypotenuse. Therefore, B will be equals to capital R sine R. So B equal to capital R sine R. So that is the formula we are to use and put it here. After noting this your formulas you have to use to get your A and your B, next thing to note is that the refractive index has a range. The range begins from 1.46 to what? 1.54. So that means if we finish solving, we'll still fall at this. But before then, we need to pick a value here that we are to use so that we can put it in the calculation. Now, I can pick 1.48. 1.48 falls inside here. Why I am picking this value is we need to know the value of R because we need R here. So that means from here, we say that sine R is equals to sine I all over refractive index. Therefore, R will be equal to sine inverse bracket sine I over refractive index. So we have another formula, R equal to sine inverse bracket sine I over refractive index. So these are the three formulas we need for this experiment to be performed without touching apparatus. Let's see how to make it. So let's get our A first. Now this is the refractive index we are using. Refractive index is equal to 1.48. Radius is equal to 5 cm. So we'll be using capital R to be 5 cm. You can put any radius you want. You can use 1, 2, 3, 4, 5, 6, 7, any number you want. But that number will be unique. You will use it throughout. So, having noted that, now to get our A, we say R is 5 sine what? I is 30, that is the first value. 5 sine 30, that is 2.50. 5 sine 40, 3.21. 5 sine 50, 3.83. 5 sine 60, 4.33. 5 sine 70, 4.70 approximately. That is the two decimal places. Now, before you get your B, you need to know what your R is. Your R will be equal to, for the first one, equals to R is equal to sine inverse bracket sine I over sine 30 over 1.48. Because you say let the refractive index be 1.48. So we now say shift sine bracket sine 30 divided by 1.48. So we'll be having individual value of R. The first one to be 19.75. Let's see the second one. This is for 30, the first one. For the second one, we change 30 to 40. 25.74. We change 40 to 50. 31.17. We change 50 to 60. 35.81. We change 60 to 70. 39.41. So these are the values of your angle of refraction. These are the value. We will now put it here. For the first one, R sine R, that is 5 sine 19.75. We have our B to be 1.69. 5 sine 25.74. 2.17 sine 31.17. 2.59. 5 sine 35.81. 2.93. 5 sine 39.41. 3.17. So we have gotten our answer. Look at the values we use to get it. We have gotten our A, our B, our I, our R, everything. Remember that the radius we use depends on what you want to use. That is about how to make your table. In the next video, you will see how we can plot the graph of A against B, get the slope, get the error in the slope, and state what physical quantity A represents. We have gotten our readings from the video before now. I want to see how to plot the graph. Now, before you do the graph plotting, please note that here you have to put your date, then say a graph of A in cm against what? B in cm. So after you put your date, say graph of A in cm against what? B in cm. Very important. Then next thing is to locate your Cartesian axis. Okay, I will just put my Cartesian axis. I just decide to skip 1 in case of what I'm to write. Let me see what to write. What determines where to put your Cartesian axis depends on some factor. If you see that if you put your Cartesian axis here and here, and writing figures here will make it look congested, you will see that you have to put it in the next line so that you will see what you are writing. That can be a factor to be considered. So what you do is, if you want to learn more about what we are doing in graph plotting, touch Daniel how to choose appropriate scale in graph plotting. You will see my video on that and learn more about it. Now here is B in cm. Once you write the quantity, you put the unit. A in cm. The next thing you have to do is you ask yourself, do they specify from the origin? If they did not, it means you can start from the origin, or you cannot. You may decide not to start from the origin. I personally will decide not to start from the origin. The reason being that if I start from origin, from 0 to 2.5 is far, and 2.5 you are just covering the distance of 2.5 and 4.7. So from 0 to 2.5, you now see that there will be vacancy between 0 and 2.5 because you start your plotting from 2.5. So because of that, look at what I will do. For this A axis, what I will do is, it is called vertical. I will say, let me start from what? 2 here. Let me start from 2. Then for this B, the horizontal, let me start from 1. I will say 1, 2. This first one represents X, while the second one represents Y. That means you are starting from 2. Now that will take you to know what we will put here. I will ask myself for A, which is this Y axis. What is the highest? 4.7. 4.7 minus where I am starting from, which is 2, which is not 0 but 2. 2. All over how many space? 1, 2, 3, 4. I'm starting from where the plotting is to start. That is from here, not from here. 1, 2, 3, 4, 5, 6, 7. Divided by 7. That will be giving me 2.7 over 7. 2.7 over 7. That would be 0.386 approximately. Now, if you are using 0.386, that is 2 plus 0.386, the answer plus 0.386, you will not see that this is not an appropriate number. It's not a uniform number. Now, to look for a uniform number you can use, I can decide to round it up to 0.5. Not just approximation, round up to 0.5, because 0.5 is a rounded figure such that when you use it here, you can know what you are doing. Okay, 2 plus 0.5, 2.5 plus 0.5, 3.0. You see that you can easily put it well without making much mistakes. What we mean by using appropriate scale simply means use a number that you can handle. Using this pattern, it will help you to know the closest number you can use. Whether you can use 0.1, whether you can use 1, whether you can use 2, and all have you. This is not an appropriate number. It's not a uniform number. So I'll take it to 0.5 and use it well so that it can work well. Then this is 3.5. This is 4.0. This is 4.5. Highest number is 4.7. Okay, 5.0. You can see everything is well accommodated. Then come to horizontal. We started from 1 because 1 is closest to 1.69. It's closest to it. Instead of starting from 0, which is further from 1.69, start from 1. Somebody can say, let it start from 1.5. But I decided to start from 1 to see that also by putting the scale, everything will balance well. Okay, 3.17 minus 1. 3.17 minus 1 will be giving me 2.17 all over 1, 2, 3, 4, 5, 6, 7 all over 7. 2.17 divided by 7, 0.31. Now, if I'm using 0.31, this 0.31 will be difficult for me to handle. 1.31, 2.31, 3.31, 4.31, 5.31. It might be very difficult for me because it is in 2 decimal places. Now I can say, let me take it to a simpler number. Take it up to a simpler number I can handle. This is 0.5. I can handle 0.5, and because of that, I will use it. 1 plus 0.5, 1.5. 2.0, 2.5, 3. You see how it's sweet while writing it. I don't need to press calculator because I am using a simpler number I can handle. But if it is 0.31, 0.31 plus 1, 1.31 plus 1, at a point you might say, let me use calculator so that you will not make mistake. But with 0.5, it will be fluent while pronouncing it. This is 3.5. The higher is 3.17, so 3.5 I've covered it. You can see we have gotten our scale. You can now come and say, for my scale, in 2 cm represent this minus this 0.5. 0.5 Now I will not write unit. What I will write is centimeter, because unit of this is centimeter. In or on a cm axis. Then 2 cm represents 0.5 cm in BCM what? Axis. We have put our scale. That means your date, your title, label your Cartesian axis, then your scale. Very important for you to do it before plotting your graph. Now what you now do is 2.5 against 1.69. 2.5 against 1.69. 1.69 can fall around here. Then 3.2 against 2.17. 3.2 against 2.17. This is around here. 3.83 against 2.59. 3.83. This is 3.5. 3.83 should be around here against 2.59. Then 4.33 against 2.93. 4.70 against 3.17. So after putting your point, next is to what? Yes, we have succeeded to put our line of best fit on it. Now next thing is to put your triangle so that you get your slope. To put it, make sure that it covers at like 2/3 of your graph. Make sure that the triangle is a big enough. You know that slope of a straight line is always collinear. Yes, so whether you make it to be big or small, you will get the same slope or a close range slope, a similar slope. Yes. So we have succeeded to locate our what? Triangle. Here we'll be changing A, and here we'll be changing B. Okay? Then next thing is for us to get our what? The final value for your slope. Here is 5.5. 5.5 minus, here is 2.5, which should be giving you 3 cm. Then for here is 3.6 approximately. Then here is minus 1.6. That will be giving you 2 equal to 2 cm. We are using approximated answer from the graph because we are using a sketch of the graph, not the real standard wire graph. So what you will do is that you will now say slope equals to change in A over change in B, and that will be 3 cm all over 2 cm. That will be giving you 1.5. This is the refractive index of this graph. Prism. Yes. So we have been able to get it. Remember we said it has a range. That the range is 1.46 to 1.54. Answer we got falls in the range, so we'll mark it good. Now we have gotten the slope. Estimate the error in the slope. Wow. In this, only one point is very close to the line but not on the line. So that one point that is very close to the line, I will put my ruler on it. I'll put my ruler on it such that I can get a line that will be parallel to the line of best fit. So look at the point and look at the line that is parallel to line of best fit. So what I will now do is that once I put the line, I will now put the ruler vertical. I'll put the ruler vertical, so I am to get this point. And also get this point. I can call this is 3.5, this is 3. This is 3, 3.1, 3.2, 3.3, 3.4. This is 3, 3.1, 3.2, 3.3, 3.4. 3, 3.1, 3.2, 3.3, 3.4, then 3.5. So I can take here to be 3.4, take here to be 3.3. Now, error in the slope SG equals to 4W over NR, where your W is your vertical scatter, which you get from putting your ruler parallel to your line of best fit and locate it to that point that didn't enter in the line. If they are two, when you put this parallel line, you also put the other one, the same parallel to the line of best fit. That is, if they are two, look at your line of best fit, this line fell out, this point fell out. What you do is you draw a parallel line, then use your ruler, place it vertical, and what? Connect it. Take the value, subtract. That is what we mean by vertical scatter. This is what we call vertical scatter, W. But if it is only one point that fell out, put only one parallel line, then what you now do, put your ruler and get a perfect vertical line. Take this value, that is it. Then this minus this, you get it. So with that, 4 times W will now be 3.4 minus 3.3. That is 0.1. 3.4 minus 3.3. That is 0.1. All over any means how many points do we plot? 1, 2, 3, 4, 5. 5 points. Arrow means your horizontal minus this minus this. Then you start having 3.17 minus 1.69. 3.17 minus 1.69. That is 1.8. I will write 1.8. 1.48. So the arrow means range of the horizontal, the highest minus the lowest, you write. Then N means the number of points you plotted. 4 is constant. W means your vertical scatter. You now get the value. The value will be 4 times 0.1 divided by bracket 5 times 1.48. That will be giving you 0.054. 0.054. No unit. Refractive index of a glass has no unit. That means our slope is 1.50 plus or minus 0.054. 1.50 plus or minus 0.054. That is how to package your slope. Okay? Now we have gotten our slope and we have gotten error in the slope. They said state what physical quantity A represents. From your Snell's law said that sine I over sine R will give you refractive index. Now from this experiment, you notice that it is A over B. Change in A or over change in B will give you refractive index. That means that A is equivalent to sign of incidence. Everything you are seeing there is excellent. But because I am training my students to be genius, I just want to share some of those things I am training them with. Yes. Those table, you will see this table there. This is table of value in that video. Table of value in that video. My student will not submit this table. They will not submit it. Why? The reason is because, look at, this is talking about length, centimeter. They will use the genius mentality I have put into them, which is that they should observe reading accuracy of every measuring instrument. They have to observe reading accuracy of every measuring instrument. Why person this? If a student go and submit this as a table of value, e no bad. But if that student is to get 9 over 10, if the student get 9 over 10 here, the one we will do here will be 10 over 10. This type of video you see me posting, I will now be doing it on my membership own, because I will do it for many practicals I will upload. Yes, so that you will learn. And so if you didn't join that membership, what you get? Why will you be learning all these things? Yes, you have a lot to learn. You have very big things, many things to learn. Now, what do I mean by reading accuracy? Reading accuracy simply means the smallest measurement you can get in that measuring instrument you use to measure out your values. If you perform this experiment, you will use ruler, because this is centimeter. You can use 30 centimeter rule or 1 meter rule, that is 100 centimeter rule, to do your measurement. So what we mean by reading accuracy? This is a sketch of what we call a ruler. Here is 0, here is 1, here is 2, and they are in cm. Between here and here, you will see tiny line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You will see a tiny line of 10 boxes, 10 lines. Now, how do you know the least measurement you can get from this centimeter rule? This is a centimeter rule. How you know it is, you say 1 minus 0. 1 minus 0 will give you what? 1, right? All over, how many small boxes do you have? 10. All over 10. Now say 1 over 0, 1 minus 0 over 10. That will be 1 over what? 10. Equal to 0.1 centimeter. That means that the least measurement I can get here is 0.1 centimeter. So that is why in measuring a ruler, you will say, in measuring anything using ruler, you say 0. This tiny one, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. That means it's going by 0.1 centimeter. And so, this measurement you see here must go by that 0.1 centimeter. Look at 2.5. 2.5. Look at where the number is. Look at where the number is. Look at the number stop here. This one, 3.21. Please, do we have any other one or number written here? The answer is no. The answer is no. And so, what it means is that I have to approximate this. I have to approximate it. To approximate it to 1 decimal place, I will have it to be 3.2. So if I have 3.2, if I put 3.20, you know bad. We are just putting that 0 to beautify it. Are you getting it? For the 3.83, watch, we don't have any other number here. It stopped at 0.1. And so what you do is that you clean this and replace it with what? 0. When they are seeing it, they will know that you are a genius trained by the Chidons. This one is not about hailing myself. I'm just telling you. They will know that you are observing reading accuracy, the maximum error you can get from that measuring instrument. So, see, tell me why you shouldn't join that channel, that membership. Click that channel, click this one and click subscribe. Tell your friend to click subscribe. Because all those videos you are telling me, light, cantilever, bending moment, electricity, I will start posting them there. That's why I created it for practicals only. So join there, or tell your young ones to join it for his success to be guaranteed in practical physics. Okay, let's see. That means here I'll be having 2.50. It's obeying 0.1. Here I'll be having 3.20. Is obeying. Are you getting it? Here 3.80. Here 4.30. Here 4.70. Obeying 0.1 reading accuracy. I mean the least measurement you can get from that meter rule, because we use meter rule to measure this. That is the distance from here to what? The distance from here to here, and the distance from here to here. So we use meter rule to measure this distance and use meter rule to measure this distance. So you must observe. That means what you mean by that reading accuracy is that you can't get 3.83 in a meter rule. What you can get is 3.8. That is what we mean. You can't get 4.33 in a meter rule. Look at it now. Assuming here is 3, for instance, now, and here is 4. 4.1, 4.2, this is 4. 4.1, 4.2, 4.3, 4.4, and so on. So if I say 4.3, the highest thing I can get is in between that 4.3 and 4.4, which should be giving you 4.35. That is the middle you can get. They will take it that you got it in between 4.3 and 4.4. When you have 4.3, 4.4 and 4.3, in between there will be 4.35. That is the highest you can get. But anything 4.3, you can get this 4.35 because it's in between 4.4 and 4.3, right? Then anything 4.31, 4.32, they will ask you, how did you get it? Are you getting it? So that is why it is good for you to observe reading accuracy of a measuring instrument. So you will be having this to be the table you will submit. Then for this one, I will approximate it to 1 decimal place, because all these are going in 1 decimal place. All this 0 you are seeing attached is for beautification to be in 2 decimal place. But look at what you can measure. The 1 decimal place is what you can measure out. So this is 1.70, 2.20. I'm approximating it. 2.60. So this one will be 2.90, and this one 3.20. That means I can measure out this from my what? Meter rule or centimeter rule, because we are dealing with centimeter rule. This is A in centimeter, B in centimeter, then I in degrees, 30.00, 40.00. That one, this one we are giving to us. They were given to us. So when you just do this finish, you write table of values on it and submit. This is 10 over 10. Yes, whenever any lecturer sees this or any teacher sees this, he will tell you you are a genius. For you to work, be able to capture this using reading accuracy principle of any measuring instrument. Then when they see this, they will know you have to get 9 over 10. That 1 mark will be deducted from you. Are you getting it? That is why every of my videos come step by step. We have done how to get the table. We have done how to plot the graph. All this you just did here, it will not affect your graph. Yes, I'm just telling you.